Welcome to the Research Cortex. Come join your friendly but snarky Silicon Valley mathematician for another math snack. We'll talk about another fallacy today, and one that is, in my experience, the most common one to spot in the wild outside of mathematics: the proof by example. So what is the proof by example, and why have I put those pretentious quotation marks around it? Colloquially, the proof by example boils down to the following assertion: every example I come up with works, so the statement must be true. We also call that a proof. There's also a sneakier cousin to this. I've never found an example where it doesn't work, so it must be true. Now, some of you are probably already shouting your own illustrations of this at Math Dora the Explorer here, and that's precisely the goal. But let's take a look at a mathematical version of this fallacy to see how it can give us some trouble in mathematics as well. Suppose I don't know a single thing about the behavior of the function x squared on integers. We'll just focus on integers for this example. The most natural thing that I can do, if I'm just exploring something I don't know, is to put some examples into the function and see what comes out. So let's try a few. Well, let's see. 1 squared is equal to 1. Sure. 3 squared is equal to 9. 5 squared is equal to 25. 7 squared is equal to 49. Wow, every time I've found an example, the result is an odd number. So I'm going to propose the following statement. If I put an integer into f of x equals to x squared, it returns an odd number. In fact, I can find infinite examples where this statement is true. I will never be done showing you how many instances that I can find to validate this statement. Before anyone loses their voice by shouting the obvious counterexample to this statement, which is the right rebuttal by the way, let's discuss what went wrong. Clearly, it's not hard to find an integer whose square is not odd. 2 squared equals 4. That just ruined my statement right there. That's certainly not odd, and 2 is certainly an integer. But what was the strategy that you used to debunk this? You likely recognize this fallacy because if you look back, I only tried odd integers in the first place. I didn't just try a generic integer, I restricted my examples. That's why the proof by example is not a proof. It's just me listing evidence. Evidence is a good thing. We make decisions based on just evidence all the time. Sometimes we don't have time to prove something. Sometimes it's impossible to prove it. Sometimes we don't need to have a proof to make a good decision. But evidence is not proof. If you want to exercise this notion, pay attention the next time you're reading something and look at the number of times the word proof is used interchangeably with simply the display of evidence or examples. Thanks for joining me today for this math snack. Take your newfound, or maybe just newly formalized, knowledge and always keep asking questions. Be sure to visit the Research Cortex to check out our research in mathematics and other videos, and feel free to use the contact page there with any questions. You can also follow us on Twitter at @ResearchCortex or me at @MathPocalypse.